Hello, algebra students, and welcome to topic 3.2 video 1 covering linear functions. All right, so this is going to kind of tie in what we talked about last lesson about functions with last topic 2, over our linear equations, right? So when we talk about linear functions, you're going to see this formula a lot, slope-intercept form, y equals mx plus b, right? However, you might see something change a little bit about the y going forward. Maybe it's going to wear a different costume or be replaced with something. So let's get right into the notes and find out what we're talking about. Okay, so it says example A, how can I represent a function rule? Okay, so if we have an equation y equals 5x plus 1, which is a slope-intercept form equation, how would we write it using function notation? Okay. Well, what we're talking about here is function notation is that we're saying, okay, we want to have an element in the domain, a variable, an x, that's our input for our function, an input, right? So notice here, this right here, this big thing is called the function machine. Mr. Berkman, my sophomore honors algebra 2 teacher, used to call it the function machine, right? And he said, your x's, your elements of the domain, your inputs go in to the function machine. Your input goes in. And then what happens is it goes into the function, this 5x plus 1, and it comes out as an f of x. This f of x is the same thing as our y. This f of x is y's costume for the day. But again, it's just what you get out of the machine. It's the output. This f parenthesis x is read as f of x. It's not f times f, f times x, it's f of x. So function notation is just a way to write an equation. Typically it's y as a function of x. So instead of putting y equals 5x plus 1, we're simply going to take the y and replace with f of x. f of x equals 5x plus 1. And this is what we mean by function notation. No big deal. No big deal. Input an x, you get out a y, we just call it f of x now. No big deal. All right. All right, so let's keep cooking. All right, so here we go. So now, what are we going to do when we evaluate a function? Well, it says, what is the value of g of x? So again, we're not talking about f of x, we're talking about g of x. Not a big deal. It's just a letter. G of x equals 5x plus 1 when x equals 3. So they are giving us this value of x equals 3 to input into our function g of x equals 5x plus 1. So here's what we're going to do. We're going to take the function machine. We're going to input a value in the domain, an x value. We're going to input 3. It's going to go into this function. So we're going to have 5, but we're not going to have x anymore. The x is now a 3. And what's going to happen is we're going to get our g of 3 value out. Again, g of 3 is how it's written. So this is the visual of the function machine. Now, are you going to write the function machine down every time? I hope not, right? That would take you a lot of time. Let's just input it in the function. So g of 3 equals. So see how I took the x out and put a 3 in its place. Equals 5 times the same thing. I'm going to take the x out and put a 3 in its place. 3 plus 1. And now you simply simplify that right-hand side by plugging it into Desmos or using your brain. 5 times 3 is 15. 15 plus 1 is 16. So g of 3 equals 16. That is your answer. This is an ordered pair on a graph. Your x value, or your input, was 3, and your output, your y value, was 16. That is another way to think about the answers to these function evaluation questions. Notice that the g and the 3 did not separate. One of the common things as you think of is that the g is being multiplied with the 3, so you have to divide by 3 for some reason. No, it's notation, g of 3. All right, very good. Okay, next one. All right, so It says the cost to make 4 bracelets is shown on the table. How can you determine the cost to make any number of bracelets? We are going to write what's called a linear function rule, right? Now, when you do this linear function rule, it's going to be in the form of slope-intercept form, y equals mx plus b. But again, we're going to do f of x equals mx plus b today, mx plus b. So we need to find our slope and our y-intercepts. Well, this table is going to give us the slope because this table is a set of ordered pairs on this linear graph. The number of bracelets will be our x value and the cost will be our y value. So what we're going to do here is we're going to look at how are the x's and the y's changing, right? If you do slope, right? Slope is change in y over change in x. It's also called a rate of change. So what we're going to do here is we're going to look at the change in the y's, right? Let's look at the y's first because that's the top number. So how are we changing from 17 to 32? Well, you can simply subtract 32 minus 17, or you can count upwards. But whatever way you do it, you are adding 15 to 17 to get 32. What about from 32 to 47? Again, subtract them, or see what are you adding to 32 to get 47? You're also adding 15. And then what about from 47 to 62? Again, you're adding 15. So notice that the change in y is constant, plus 15. The change in x is simple. You're counting by 1, so that's adding 1, adding 1, adding 1. So notice that this, because your change in y is constant or the same, and your change in x is constant or the same, this is going to be linear. That's how you determine whether it's linear or not. You look at the changes in y and the changes in x. So again, this is going to be our rate of change or our slope, rate of change. And it's going to be the change in y, which is $15, over the change in x, which is 1 bracelet. So that means your rate of change is $15 per bracelet. Again, this is your slope. This is your m value, a rate of change. So now we have, I'm going to use y right now. Y equals, we have our slope of 15, 15x plus b. Well, now we need to find b. And to find b, we're going to take one of these ordered pairs from the table and substitute it for x and y. Why not use the smallest numbers? Why not use the 1 and 17? This is going to be our ordered pair, 1, 17. This will be our x and y that we plug in right here. So now it's going to say 17 equals 15 times 1 plus 2. And now we're going to solve this for b. We're going to simplify that first. So 17 equals 15 times 1 is just 15. And then we'll subtract the 15 to the other side to get the b by itself. 17 minus 15 is 2. 2 equals b. And now you have your b value as well. So our slope-intercept form, y equals, m was 15x, and then our b is a positive 2. In function notation, f of x equals 15x plus 2. And that is our linear function rule for this set of data. And now you could plug in any number of bracelets for x, and you'll get out how much it's going to cost for y. All right, so this was the end of video 1. Video 2 is coming up right next.